Hi everyone, I hope you are doing well. So in today's video, I'll be going through the 2019 Specialist Maths Exam 1 for the Northern Hemisphere. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And there guys, let's smash through this video. Question 1. A 10 kilogram mass is placed on a rough plane. Okay, rough means that there is friction. So we know that there's going to be friction. That is inclined at 30 degrees to the horizontal, as shown in the diagram below. A force of 40 newtons is applied to the mass up the slope and parallel to the slope. So up the slope, which is like this, and it's parallel to the slope, so that is going to be 40 newtons. There's also a frictional resistance force of magnitude F that opposes the motion of the mass. Of course, because we're moving it up there and it's rough, there is going to be a frictional force that always opposes that motion. So we call that F. Great. So A, find the magnitude of the frictional resistance force in newtons acting up the slope if the force is just sufficient to stop the mass from sliding down the slope. In other words, we don't want what we want is, if we don't want it to slide down, it means we want it to be equilibrized, meaning that acceleration is going to be 0, and the force net, we want the acceleration to be 0, also meaning that F net, your sum of all forces should be also 0. So let's just kind of, just put all the forces. So that's we're going to have a normal force, and this can be broken down. Perfect. So what I'm going to do is I'm going to resolve all those vectors in this direction. I'm going to take, because what we're doing is we're moving at 40 newtons up the plane. That's going to be our acceleration. If there was acceleration, it's going to be accelerating up, so we're going to make it as positive. Whereas this way over here, down the slope, it's going to be negative. So let's add all those forces. Remember, the sum of all forces is 0. So it will be 40 minus F minus 10g sine 30 degrees, and that's all going to be equal to 0. Hence 40 minus 10, so sine 30, which is just sine pi over 6, is just a half. Should be equal to F. Hence F is equal to 40 minus 5g. Now 5g, let's think about it. So 5g is, we know g is 9.8. So we can write it as 98 over 10. We can cancel those out. So it's just 98 divided by 2, which is 49. Let's write 49 here. Minus 49. Hence, your frictional force is -9. And it makes sense. Why do we have that negative? Because remember, the negative, it's showing us the direction of the force, which of course makes sense. It's going down the slope, whereas this one has to be negative. Hence, perfect. But we want the magnitude, so be careful. Just make sure to exclude that negative. So it's going to be 9 newtons. Pretty much that's it. Easy. Next question. An additional force of magnitude P newtons is applied to the force up the slope and parallel to the slope. The sum of the additional force and the frictional resistance force of magnitude F that now acts down the slope is such that it's just sufficient to stop the mass from sliding up the slope. In other words, same conditions where we want the acceleration. There's no acceleration, so there's no movement, hence your acceleration 0. And also it means that your net force must also be 0. But now we have an additional force. So we're going to have a force like this. So it's still up the force, and we're going to call it as P. And yeah, let's just, again, resolve the vectors. So for the sum of all vectors, so P, that'll be that, plus 40, minus F, minus 10g sine 30 degrees. That all should equal to 0. Luckily, we know that F is 9, so it'll be -9. We know also this all expression is just 49, as we showed in the other question, so it will be minus 49, and that all should equal to 0. Hence, your P, your force P is what? So it will be 49 minus 40 plus 9. So that'll be 18. overall that'll be, so your force will be 18 newtons. Great. That's it. Let's move on to question 2. Question 2. A cubic polynomial has the form this, where B and C and D are elements of all real. Perfect. You should straight away know that if the coefficients that are all real, for example, for this one, what do we know? We can use the complex conjugate root theorem. Given that a solution P of Z is this and that this is that, find the values of B, C, and D. Okay, so we have a solution of Z1, which is just 3 minus 2i. We know by complex conjugate root theorem, by complex conjugate root theorem, Z2, another solution should be the conjugate, 3 plus 2i. Done. So we already have two, and we also have another solution. Remember, if you it's pretty much saying if you sub in -2, that equals 0, so it's a factor. So we can say another solution is just -2. Yeah, so we just want to make sure to now, expand them, like make them into factors and expand the whole expression. You should know that when you have two complexes, for example here, and we can create a quadratic, this is the form that we can use. It will help us a lot. So z squared minus alpha plus beta z plus alpha beta equals 0. Where alpha and beta are your roots, for example, these ones here, you can make them into factors and expand them. It takes too long. Whereas if you use this form, you can do it in like 10 seconds. So in this case, our alpha, one of the roots is 3 minus 2i. Let's call that. And the other, we'll call beta, your other root is 3 plus 2i. Hence, let's put that in that form. So z squared minus, what's alpha plus beta? If we add them, we get 6z. And then just find the, if you multiply them, so it'll be 3 times 3, which is 9, minus 4i squared, which is just this. So it'll be 13, pretty much. It'll be plus 13. Done. We have just expanded them quickly. And okay, and we already know this is a root, and it's a real number, so it's going to be just z plus 2 equals 0. And pretty much let's expand this and get it in this form. So expanding this, we're going to get z to the power 3 plus 2z squared minus 6z squared minus 12z plus 13z plus 26. Okay, I'm putting this all together. So z to the power 3, 2 minus 6, which is negative 4z squared, plus z plus 26. Hence, your b value is going to be negative 4. Your c value is going to be 1. And your d value is going to be just 26. Done. Those are your answers. Let's highlight those. Easy. Next question. Question 3. The number of cars per day making a U-turn at a particular location is known to be normally distributed with a standard deviation of 17.5. Okay. In a sample of 25 randomly selected days, a total of 1,450 cars were observed making the U-turn. So, in 25 days, the total, be careful, they're saying the total. Make sure, read the question carefully. The total of the in those 25 days, 150 cars were observed to making a U-turn. Pretty much what we want to be careful with the question is, so how much per day we're making in those 25. So how many per day we're making those U-turns. So what we're going to do is just 1,450 divided by 25. So it will help us with the question. So what's 1450 divided by 25? Okay, so what's going... So if I 1450, 25, I know that if I put a 5 here, so it'll be 125, just 200, and that'll be 58. So it'll be 58, pretty much. In one, so per day, so the number of cars per day making a U-turn, the sample is, so your sample mean is going to be 58. Be careful, yeah. This is, I think, where a lot of students would make the mistake by just, without reading the question, they would take this as your sample mean, which is not. Be careful, yeah. So we've got that, perfect. So that's our observation. A sample, a total of this, okay. Based on this sample, calculate an approximate 95% confidence interval for a number of cars making the U-turn each day. Okay, perfect, each day. Use an integer value, multiple of the standard deviation in your calculations. Easy. So let's write the formula for calculating the confidence interval. So it'll be, your sample mean minus, especially because we're doing 95%, it's going to be 2 S over root N. And for my plus 2 S over root N. That is your confidence interval. So let's sub on all those values. So we have, in this case, we have 58 minus 2. Well, S is 17.5, but it's very ugly. Let's make it into fractions. So it's like 35 over 2 pretty much. So it's, okay, so we're saying 35 over 2 divided by root N. And our N is 25, so it'll be 5. So what's 35 over 2 times 1 over 5. That's, so it's overall 7 over 2. 7 over 2. Okay. We can just write here 7 over 2. Same thing for this one. So we have 58 plus 2, 7 over 2. Those actually 2's cancel out, so we can, it's just minus 7. 58 plus 7. Hence, your confidence interval is 51, 60, what is it? So 65, is that right? Yes, so yeah, 65, yeah. I just want to make sure I'm right. So yeah, 260, yep, 65, perfect. That is your confidence interval, done. Nice. Next question. The average number of U-turns made at the locations is actually 60 per day. Okay. Find the approximation correct to 2 decimal places for the probability that, so we want the, every time I hear probability, I'll write that, the sign. The probability that on 25 randomly selected days, the average, okay, so we want the average number of U-turns is less than 53. So we want the average, your sample mean, is less than 53. But remember, given that we know the true value, which is your actual mean, is 60. Great. So we're going to say probably we're going to change this to Z is less than 53 minus 60, all divided by your standard deviation, which is S over root N, which is still 7. Yeah, so it's still 7 over 2. That's good. So 7 over 2. And yeah, so 53 minus 60, which is going to be negative 7. And that's divided, which is just 2 over 7, which is negative 2. Pretty much this whole expression is negative 2. Okay, now that's easy. If you remember drawing a normal distribution, we know that when, for example, let's say this is your mean, which in terms of Z is 0, and we know if this is negative 2 and this is 2, we know that this here is 95%. And what does that mean? Well, it tells us that the other part, which is 0.025, these are both 0.025. So, if we want Z to be less than negative 2, which is in this case this part over here, which is 0.025, that's it. So 0.025. Let's look at the question. What do they say? Correct to 2 decimal places. So 0.03. And that's it. That's your probability. Done. Easy. Nice. Question 4. Evaluate, okay. This is not too bad because just you should realize that, okay, if we use substitution, so that's right. I've seen this question before during past exams. So if we let u equal log e of x, and hence then dx is just 1 over the derivative of this, which is just 1 over x, which is just overall x du. Hence we have this beautiful expression, and what we can do is rewrite this whole. So of course the terminals have to change. So if I sub them, like what is the value of u when I sub in e to the power 3? So log e to the power 3. What I can do is take that power to 3 in front, and that'll be it'll just be equal to 3. That's for that one. And what about the other one? Other terminal, u is equal to the same. So, but it'll be 4. So this will be 3, and this will be 4, pretty much. So that's nice. So log e to the power 4 is just 4. So 1 over x, we know log e is just u, so we can put u in there, times, what's your dx? We said that it's x du. Hence we can cancel those x's out. Hence your final 3 to 4, 1 over u du, which is very easy to simplify. It's just the log e absolute value u 2 4 to 3, which is just log e of 4 minus the log e of 3. Hence your final answer, log e 4 over 3. That's it. Done. Yeah, that's pretty much it. Nice. Next question, let's have a look at this. A triangle has vertices A, B, and C. Find the angle A, B, and C. Okay, so let's just draw a nice diagram here to show us this. So if we have a triangle like this, so we have a triangle, and so let's call this A, this is B, and C, and we want to find the angle A, B, and C, so it means this angle over here. That's going to be your theta, okay? So we know that to find the angle, so B is our mid, so we need to find these two vectors. So we need to say that B to C, the vector B to C, multiplied by B to A should equal to the magnitude of B to C multiplied by the magnitude of B to A, and that all should equal times by cos theta. That's the basic formula. So we want to find theta. So let's find BC. BC, whenever you see this, whenever you see you find the first term, so B, you have to make sure you put a negative and write OB. Plus, then the other one just becomes just OC. So that is the faster way to kind of simplify this. You don't have to, draw a diagram. You just, whenever you see the first term, so B, you write negative OB, and C is that. Hence, what is OB? Which is this over here. So it'll be negative I plus 2j minus 3k. So C is plus 2I minus 2j plus root 3 plus 3k. So simplifying that, we got I, j's cancel out, that's great, plus pretty much root 3k. Yes, great. So we have that. That's your B to C, and now we just need to find B to A. So B to A is negative OB. Remember the first term is going to be negative, plus O to A, which is what? So OB is, again, just negative I plus 2j minus 3k, or A is just plus root 3 plus 1 I minus 2j plus 4k. I want to make sure I've done that right. So negative I Okay, that's good. Okay, looks good. And, you know, simplifying this much further, we get root 3i. Did j still cancel out? So root 3i, so that's that. Great. And 4 minus 3, which is plus k. Hence we can, yeah, that's, okay. I'm going to rub all this information out. So to make now my information, oh, oopsies. So I'm going to rub this all out because there isn't enough space. And I'll just cancel that out and I'll put this on top. That's your B to C. And hence, what is your B to A? Let's write B to A is equal to this expression right over here. And that's it. I'm going to just cancel this out. And yeah, now, okay, we've got that. Now we need to find pretty much the dot product of both of them. So B to C dot B to A as well. Well, what's 1 times 3, which is just root 3? And what's root 3 times 1, which is plus? So it's overall 2 root 3. That's your 2 root 3. So what's then the magnitude of B to C? So it's just going to be the square root of 1 squared, which is 1, and root 3 squared, which is just plus 3, which is just 2. And it's the same for BA, as we can see. So the magnitude of B to A is the same, which should also be 1 plus 3, 2. Now let's put this in this formula and find cos theta. So overall, it's going to be 2 root 3 equals 2 times 2, which is 4, times cos theta. Hence, cos theta is just root 3 over 2, which is just, you know, your basic angles. So hence, what is theta? It is just pi on 6. Done. That's your answer. Nice and easy. Oops, what have I done here? That was not too bad. Let me just write it nicely. So pi over 6. Done. I hope that's right. Then find the area of the triangle. Okay, so we know to find the area of a triangle, especially this kind of triangle. What do we know? It's also in your formula sheet, the area of a triangle. It's just going to be area is equal to half BC sine A. Now, what does that take? For example, we'll consider, because we know at the angle of this, which means that it's this side A, and let's call this, you know, B, and this is C. So what is the magnitude of B, which is just B to C, which we already know? It's 2. So both of these actually just have 2. The magnitudes are 2, 2, 2. And now this angle here is just pi on 6. So we can write pi on 6. So your area is going to be half 2 times 2, which is just 4. And what is sine pi on 6? So you should know sine pi of x is just a half. So 4 times a half is 2, and 2 times a half is just 1. Hence, your area is just 1 unit squared. Done. Next question. Let's go to that. Question 6. Part of the graph of y this, where x is greater than 3. Okay. And it's shown on the graph. Find the volume of the solid revolution formed when the graph of this from x equals 4 to x equals 6 is rotated about the x-axis. Give your answers in the form of a log EB, where a and b are real numbers. So what's happened is, if I just draw straight lines here, a straight line here, and imagine just like kind of reflecting it along the x-axis. So something like, oh, it's not the nicest, but like pretty much something like this. And they're just getting rotated. And we want to find the area of this rotation. That's easy. You should know the formula. So this is what you do. You're going to write volume is equal to pi, always pi, integral. Okay, where is it being rotated? It's rotated along the, about the x-axis. So we have to write dx here. And these terminals have to be in terms of x also. So because we've already given us 4 to 6, so that's good. And now the inside has to be y squared. So what's our y squared? Well, we know y, and imagine squaring it. So it's just going to be 4 divided by x squared minus 4x plus 3. And we can take that constant out. So to make our life easier, actually, just take that constant out. 4 pi. So just 4 pi. Great. And that's 1. And, well, just from this, I know I can't factor that out. So I'm just going to complete the square. So if I was completing the square for x squared minus 4x plus 3, it's going to be x squared minus 4x plus 4 minus 4 plus 3, which is just x minus 2 squared. So 3 minus 4 is 3 minus 4. What's happened to be minus 1. Is everything great? Yes, looks good. So let's write that down. Volume. So plus 1. Minus 4 plus 3 minus negative 1. Okay, great. Just trying to think if I made any mistakes. Great. 4 pi hence is going to be the integral from 4 to 6, 1 over x minus 2 squared minus 1 dx. Great. And so, how do we integrate this? That's, what do we do? Okay, let's think. So, let's rotate about the x-axis. Give your answer in the form of this. I'm trying to think. What can we do here? So, have a plus 4 plus 3. Okay. Okay, what about if we let u sub u? So let u equal x minus 2. So then hence dx is just du. So let's use that. Maybe that can help us. So 4 pi, the integral of 1 over u squared minus 1 du. Okay. Oh my god, what am I doing? Oh my god, no. I am such an idiot because no, don't follow what I just did. You can factor that out. I'm just trying to I'm struggling. I'm like, normally, why am I not, why isn't it working? I'm trying to think of ways. You can factor this we're going to have to use partial fraction form. I just looked at, why am I, okay, so if I was factoring that out, what happened to me? Did I just get a blank? So 3 to 1, negative. Yes, that works. So we can pretty much write this as the integral for 4 to 6, 1 over x minus 3 and x minus 1. So we have to use partial fractions. Wow. That was not just that. Why did I just not think about that? So break that down. Let's decompose it. So of course we're going to have an a divided by the first one, which is x minus 3, plus b, and it's going to be x minus 1, and that overall should equal to 1 over x minus 3, x minus 1. So multiplying all these, so we get a x minus 1 plus b x minus 3 all should equal to 1. So expanding this out, ax minus a plus bx minus 3b equals 1. Hence, a plus b x, yes, plus negative a minus 3b should equal to 1. So we know that hence a plus b equals 0, and negative a minus 3b is equal to 1. Adding both of them, we cancel out those a's, so it's just like 1 minus 3, which is negative 2b equals 1. Hence, your b value is just negative 1 over 2. Great. Since what's your a? Remember, a is just going to be negative b, so a is just going to be positive half. Done. So let's pretty much rewrite this. So we can rewrite this whole expression as, half x minus 3 minus a half x minus 1 dx. Okay, I want to pretty much put this all, like, make it little and put it over here, somewhere around here. And now, okay, I can take the half as a common factor, so like it'll be 2 pi here. This will be 2 pi. And so I can take all those halves out. That's going to make my life easier in terms of simplification. So I can say that's half and that's half. And yeah, now just use your basics. So 2 pi, integrating the first part, is just going to be log e, absolute value x minus 3. Actually, we don't even need to have those absolute values because we know that x is greater than 3. For example, if x is greater than 3, think of like the number 4. That's greater than 3. And if we sub in here, like 4 minus 3, it's always going to be greater than 0. Hence, we don't actually need those absolute values. So just write it as x minus 3. Minus log e. Also, when you put absolute value x minus 1, we don't need them. X minus 1 goes from 4 to 6. Hence, volume is just 2 pi log e x minus 3 divided by x minus 1, 4 to 6. Volume is just going to be 2 pi. So it's going to be first be log e. If I sub in 6, it's going to be 3. 6 minus 1, which is 5. Minus log e. If I sub in 4, it'll be 1 on top. Will be 3 at the bottom. So closing that. Hence your volume is just going to be 2 pi log e. So what's 3 over 5 divided by, so it'd just be 3 over 1, which is 9 over 5. Okay, and is that all? I want to double check. It says in this form where a is a real number, b is also a real number. Great. Yeah, that's pretty much it, which we can write units cubed. Wow, I don't know why I struggled with that question. I just got a blank. I don't know why I even didn't factorize, because I looked at it, I'm like, I don't think you can factorize this, but then, be careful, guys. Make sure you always try factorizing first. Always factor first. See if it doesn't. If it doesn't work, then use complete the square. Okay, that's it. Next question. Question 7. It says, given that 3x squared this, find d squared double derivative at the point this. Okay, so we're going to, of course, use implicit differentiation here. So if I derive everything, so writing d dx of 3x squared plus d dx of 2xy plus d dx of y squared and d dx of 6. Let's do that. So here, it's just going to be, the derivative of this is just going to be 6x. The derivative of this is you're going to have to use the product rule. So it's going to be, you'll use 2x, so we'll write it 2x. The derivative of y is 1, but remember, because it's in terms of y, we have to multiply, that 1 by dy dx. So it's just going to be dy dx plus y, and multiplied by the derivative of 2x, which is just 2. So it's going to be overall 2y. Done. Plus the derivative of 2y, it's going to be just 2y, but multiplied by the derivative because we just derived it in terms of y. Plus the derivative of 6 is a constant, so it's going to be 0. And now let's just get dy dx in, on the left-hand side, make my life easier. So like dy dx is going to be 2x plus 2y is equal to negative 6x minus 2y. Hence dy dx is negative 6x minus 2y all divided by 2x plus 2y, which, because you can take the 2 out, so just make our life, so it'll be negative 3x minus y all divided by x plus y. Great. That's your dy dx. That's just one step. And let's use again implicit differentiation to get d squared dy. D squared. The double derivative. D squared y dx squared, pretty much. So again, so let's write that first down. So dy dx hence is just negative 3x minus y all divided by x plus y. Of course, we're going to have to use the quotient rule because we have two things divided to each other. So let's use that. So hence your d squared, again, like, this is going to be now d squared dx squared is equal to, so your u is going to be that negative 3x squared. So it's just going to be, first it's going to start with these. So x plus y multiplied by the derivative, which is u, which is negative 3 minus dy dx. Remember, we've deriving y, so negative y is just going to be negative 1, but multiplied by dy dx. Okay, we get this. Minus, okay, it's a lot, it's very quite big. So I'm just going to put it over here and just do it here. Okay, minus negative 3x minus y, deriving the bottom, so your is going to be 1 plus dy dx. Is that right? Have I made any mistakes? So 1 plus dy dx. Great. All divided by the bottom squared. So x plus y squared. X plus y squared. And that's your d squared dx. Okay, now let's sub in, the points for x and y 1. So if I was subbing that in, what's going to happen? So d squared y dx squared is going to be, so 1 plus 1, which is 2, negative 3 minus dy dx. Remember, dy dx is this. And imagine subbing 1, all the x equals, so x equals 1 and y equals 1. So it will be negative 3 minus 1, all divided by 1 plus 1, which is 2. So hence, it's going to be negative 2. So it'll be, it'll be negative 3 minus negative 2 minus negative 3 minus 1. Oh, it's a lot. It's very, very large, to be honest. I'm just going to put it over here so I can write more. 1, so dy dx is just negative 2. Yep, all divided by, so 1 plus 1, which is 2, and manage squaring it, so it'll be 4. Now we just need to simplify this pretty much. So hence your d squared dx squared is going to be 2. Negative 3 plus 2, so it'll be just negative 1 minus, minus negative 4. 1 minus 2 is just negative 1, which is just 4 times 1, which is 4, negative 4 pretty much. Here it's going to be negative 4, all divided by 4. So d squared dy dx squared is just going to be negative 2 minus 4 all divided by 4, which is just negative 6 divided by 4, which can be simplified to negative 3 over 2. That's the answer. Negative 3 over 2, is that right? So just, let's write it here. Negative 3 over 2. That should be your answer, yeah. Looks, oops. That's it. I hope that's right. All right, I'm going to put everything that I've written here and just kind of fit it in here by making it little. So let's put it over here. Taking this one over here. This one here. This one over here, making it little. And right over here. And that's it. Pretty much that's it. Yeah. Let's do question 8. So question 8. Find the length of the arc of the curve by this. Okay, that's your equation. From x equals 1 to x equals 2, give your answer in the form of a over b, where a and b are positive integers. Okay, let's do that. So we know that the arc length, so your length, is just going to be the integral from where you're going, so 1 to 2, the square root of 1 plus. In terms of this, it's going to be f dash of x squared dx. That's the equation. It's also written in your formula sheet. So, in this case, f of x, so I'm going to write let. We want to show that. So we want to let f of x be this equation. Remember, it's in terms of y, so be careful. You want to let it 4 over 4 plus 1 over, actually, what I can do is write this just, like 1 over 8 x negative 2, bring that 2, and plus 3. All right, so have I made, this is a very long 4 marker. Okay, so that's good. So f dash of x is what? So it'll be just x to the power 3, because 4, so what's 4 times, that cancels out, and then yes, so that's good. And then plus, so I want to do this, so 1 over 8 times negative 2 x, and minus 1 will be negative 3, so it'll be negative 1 over 4 x to the negative 3. So we can just write it as negative 1 over 4x to the power 3. Okay, that's good. And then the constant becomes 0 anyway. So okay, we got that. That's good. And then we want to square it. So f dash of x all squared is what? It's going to be x to the power 3 minus 1 over 4x to the power 3 all squared. And now let's actually just expand it. Yeah, we're going to probably need to expand that, yeah. So what's going to happen if we expand it? Well, we're going to get, so it's going to be x to the power of 6 minus, so what's 2x to the power 3, 1 over 4x to the power 3. What are we going to get? Those cancel out, and then it's just a half. So pretty much minus a half. Minus a half. And then what's 1 over 4x to the power 3 squared, which is just 1 over 16 x to the power 6. Yeah, so 1 plus 16 x to the power 6. If you're wondering what I'm doing here, you remember the form when you're, let's say you had a minus, so a, like let's say you had a minus b squared, which is just, expanded to this. That's pretty much what I'm doing. Yeah. Like minus 2, I've written, well, in this case, I put that minus, so this is supposed to be minus. A is that, and that's b, and blah, just a quicker way to expand it than to, yeah. I want to make sure everything's great. So 16 x to the, so yeah, that's good. Okay. We said needed to, looks good. So we got this, and we're going to add 1. We're also going to add 1. Remember, 1? We're going to add 1. And so 1 minus a half is just positive half. So you can just cancel this and put a positive here. Great. And then this here, I'm going to multiply everything by 16x squared, common denominator. So it'll be, what? So 16 x to the power of 12. So what's 16x 6 times a half? We get plus 8x to the power of 6 plus 1, all divided by 16x to the power of 6. Okay. All right. So, okay. This actually can be simplified because remember, let's say if we let u be x to the power of 6, this is just 16 u squared plus 8 u plus 1. The top part, all divided by 16 u. So we can actually simplify this because it's now a quadratic. So we can say 16, just 4 times 4. So 4x, so because this is in terms of u, I'm doing cross multiply here. 1. Yes, so it's this whole part on top can we just simplify to 4u plus 1 squared, where u is, remember, x to the power of 6, so let's sub that in. That's it. Great. And here also, like this here, remember, make sure you put that back, so x to the power of 6, which we can write as 4 to the power of x 3 squared. Yes, so we can write that here. So 4x to the power of 3 all squared. So now this is a beautiful expression because remember we are taking the square root of the whole thing. And if we take the square root, it just simplifies to, remember, taking the whole square root of this here, this cancels out because remember there's a squared here and also this one's squared. So we can overall write it like 4x6 plus 1 all divided by 4x to the power of 3. Now that's easy to simplify. We're going to get x to the power 3 plus 1 over 4x to the power 3. Done. Now this is very easy. Now let's integrate that. Wow, that's a lot of work we did, but it's okay. And we got to the end, so that's great. Got that. So let's rewrite this whole expression with a different color. So it makes length is going to be the integral from 1 to 2 x to the power of 3 plus 1. We can write it, bring that power there, so x to the negative 3 over 4 dx. That's it. Now let's simplify this. So your length is going to be the integral of x to the power 4 over 4. And this one over here is what? So we have this. So if I added 1, it'll be negative 2. And dividing it by negative 2, we get negative 1 over 8 x to the power of 2, yeah? Is that right? Looks good, yeah? So, okay, let's write that down. Negative 1 over 8 x squared from 1 to 2. Done. Now let's kind of simplify this. So length is going to be, so 2 to the power of 4 divided by 4 is just 2 to the power of, squared, like 2 squared, which just simplifies to like 4 minus 2, which is then 2 to the power of 3, which is just 4. Done. That's 4. Minus 1 over 8. So 2 squared is just 4. So what's 8 times 4? 8, 16, 24, 32. So that's going to be 32 at the bottom. Minus, putting that 1 is just going to be 1 over 4 and minus 1 over 8. Done. We are nearly done. Now just simplifying this whole expression, we get, so let's do it quick here, minus 1 over 3, 2, minus 1 over 4, plus 1 on 8. So it will be what? So this here, so if I 2 plus 1 all divided by 8, which is negative 1 over 8. So this here we can write it as negative 1 over 8. That's good. Because there's a 32 is a common denominator, but what's 32 plus 4? 8, 4, 8, 12, 1 to 8. So 1 to 8 minus 1, 8, 16, 24, 32, so minus 4. So 1 to 8 minus 5 all divided by 32. Wow, that's so that's going to be 1, 2, 3 divided by 32. That's your answer. 1, 2, 3 divided by 3. I need to check the answer for the one because this one's actually quite big. Units. Wow. That's your answer. Done. That took very long. Wow, 4 marks. Last question. Is this the last question? Yeah, question 9. Okay, let's look at this. Question 9. Show that tan 5 pi over 12 is equal to this. Now, of course, you should know when you see these kind of expressions, you have to use your, your compound angle formulas, or you can also use your double angle, but in this case, it's not very useful to use your double angle now. So, I'm going to say, okay, what things can give me that? So, tan something, so let's say pi on 6 plus something, which I have no idea, should equal to 5 pi over 12. That's what I'm thinking. Something, because, okay, which is just x is 5 pi over 12 minus pi over 6. So it'll be just 5 pi minus 2 pi, which is 3 pi over 12, which is pi over 4. So it's pi over 4. So two things that add up to give me that are, pi over 4. Two things that add to give me 5 pi over 4 is these two expressions. So we can rewrite this as tan of pi over 6 plus pi over 4. And remember, using the formula sheet for the combined angle formulas, it's going to be, you remember the formula? So I'll write it over here so you can see it. It's just tan x plus y is equal to tan of x plus tan of y, all divided by 1 minus tan of x multiplied by tan of y. So let's write that down. So in other words, we're saying that tan of x, which is pi over 6 in this case, plus tan of pi on 4, all divided by 1 minus tan pi on 6 times by tan pi over 4. Okay, tan pi over 6 is what? It's just 1 over root 3 plus tan pi over 4 is just 1. So we can just write it as 1 plus 1 over root 3 all divided by 1 minus, remember tan pi over 6 is just 1 over root 3, so it'd be 1 over root 3 multiplied by 1, which is just that, yeah. Which is tan pi over 4 is just 1. So we get this, and let's make a common denominator of root 3, so it'll be just root 3 plus 1 over root 3 all divided by, sorry for the background noises, so root 3 minus 1 over root 3. So what's root 3 plus 1 over root 3 times root 3 over root 3 minus 1? We cancel those out. We can simplify this whole expression to root 3 plus 1 over root 3 minus 1. Okay, and we can, I want to write it this one so negative 1 plus root 3, and this one 1 plus root 3. Why am I writing this? Because I'm going to conjugate them. Remember when you have something like a surd, to conjugate that, we're going to multiply, I'm going to multiply this side by negative 1 minus root 3. And this both sides here, negative 1 minus root 3. Hence, wow, for 2 marks. Okay, so the top part's going to be negative 1 minus root 3. So overall, and then it's going to be negative 2 root 3. Minus 3. All divided by 1 minus 3, which is negative 2. Which we can simplify. So negative 1, so negative 4 minus 2 root 3, all divided by negative 2. And that just simplifies 2, cancel all those negative out and divide them by all 2. It's going to be 2 plus root 3. And that's that's our solution, yeah. So it took very long, actually, to do that, but that's your answer. 2 plus root 3. So let's make that all small and fit that in. Done. Next question. Your final 4 marks. Wow. So we have this, and it says, find the area bounded by the graph of f of x shown above, the x-axis and the line x equals 0 and x equals this. Okay. So it will be, the area is going to be, we want it from 0 to 2 root 3 plus 6. Remember, hence meaning, I know for a fact that I'm going to have to use this expression over here, because, yeah, hence means using your previous question, do this. So I'm going to take that 2 out. 1 over x squared minus 4x plus 8. Can I factor this? So x, two things that give me 8, so 8, 1 we can say. That doesn't work to give me 4. What about 4, 2? No, that doesn't work. So this one cannot be factorize. So we're actually going to complete the square for this one. Let's complete the square. So, to complete the square for this one, it's going to be x squared minus 4x plus 4 minus 4 plus 8. This is just x minus 2 squared. So 8 minus 4 is just plus 4. Pretty much this whole thing simplifies to x minus 2 squared plus 4. All right. And what do we do? Okay. If we let u in this case, so this one looks nice. So let u be x minus 2. Hence your dx is just du. We rewrite this whole expression as 2 the integral of, if I sub in 0 into this, what happens? So it'll be negative 2 at the bottom. And if I sub in 2 root 3 plus 6 minus 2, it will just be plus 4. Let's write that down. 2 root 3 plus 4. All right. So it'll be 1 over, now x minus 2 is just u, so u squared plus 4 multiplied, so dx is just du. Done! This now is a beautiful expression because it's, the integral of this is just tan inverse, remember? So if I'm not mistaken, what was the, okay, so tan inverse, so let me just write it here. The integral for an expression like a over, like, a squared plus 4 plus, in this case, like, x squared, something, dx is just equal to tan inverse x over a. That's what the expression that I'm going to use here. It looks very similar. But so our a is, in this case, it's a squared is 4. So we need to have, wait, we have a 2 here. Why don't we just put that 2 in here? Put that 2 in here. Now this whole expression looks very, very good. It looks like it's perfect in this example. So hence your area will be, well, the integral of that's just going to be tan inverse of x over, sorry, it's going to be u. Sorry, why am I right? It's going to be u over a, which a in this case is just 2. So let's rub that out and a little bit simplify this much further. So, okay, so 2 root 3 plus 4, negative 2. The overall area is going to be 10. Okay, if I sub in 2 root 3 plus 4, all divided by 2, that's going to be root 3 plus 2. Okay, minus tan inverse of negative 1. Which hence is, we know already this is great because this whole expression is just this. That what's the angle of root 3 over 2? It is 5 pi over 12. So going back here, 5 pi over 12 minus, so tan of negative 1 is negative pi over 4. So it'll be plus pi over 4. Is that right? So tan, inverse of tan of negative 1 is negative pi over 4 and then negative. Okay, yep. Hence your area, it's going to be 10 pi. What's happening here? Let's have a look at this. So 5 pi, 5 pi over 12. 5 pi over 12. All right, so it'll be 5 pi plus 3 pi, which is just 8 pi. Would just be 8 pi over 12, which is 4, if I divide by 6, which is just 2 pi on 3. Hence, your area is just 2 pi on 3 units squared. Done. That was, this exam was all right. I'm not going to lie. It's a nice exam. Luckily, the questions were nice. Great. It wasn't too bad, I would say. I don't know, for what this question I kind of got mixed up. I don't know why I didn't even think of partial fraction. Just lost my brain there. But yeah, guys, I hope you guys enjoyed this video and learned something. Good luck to all you guys. Please make sure to like and subscribe. And sorry for the background noises. My dad's lowering them on. And yeah, have a great day, guys. Bye-bye.